हेलो स्टूडेंट, आज हम पेट्रोलियम रिफाइनिंग टेक्नोलॉजी के बारे में पढ़ेंगे। पेट्रोलियम रिफाइनिंग टेक्नोलॉजी का सबसे पहला चैप्टर पेट्रोलियम एक्सप्लोरेशन, प्रोडक्शन एंड रिफाइनिंग है, जिसके अंडर हमारा इंट्रोडक्शन, फॉर्मेशन ऑफ ऑयल एंड गैस एक्सप्लोरेशन, ड्रिलिंग फॉर ऑयल एंड गैस, प्रोडक्शन ऑफ क्रूड ऑयल एंड नेचुरल गैस, एंड लास्टली पेट्रोलियम रिफाइनिंग ऑपरेशन एंड ऑप्टिमाइजेशन। पेट्रोलियम रिफाइनिंग ऑपरेशन एंड ऑप्टिमाइजेशन के अंडर हमारा आ जाएगा सिलेक्शन ऑफ प्रोसेसेस फॉर ऑप्टिमाइजेशन इन ए रनिंग रिफाइनिंग कैपेसिटीज इन इंडिया। तो फर्स्ट चैप्टर में हम ये सब के बारे में जानने वाले हैं। फर्स्ट चैप्टर 1.1 इंट्रोडक्शन। Energy is known to play a vital and important role in the industrial and economic development of any country. Petroleum provides a relatively cheap and convenient source of energy as compared to other fuels such as coal, electricity, etc. India is the fourth largest consumer of petroleum product in the Asia Pacific region and fifth largest consumer in the world. However, in crude oil production, India ranks 22 in the world. The consumption is growing annual at 6 to 7%, while production of coal is stagnating. This mismatch between domestic production of fuel and consumption of petroleum product has increased the dependency on import to 40% of crude oil and 50% of petroleum product requirements, which amount to 25% of India's export. दोस्तों, अब हम पेट्रोलियम के फॉर्मेशन के बारे में जानेंगे। तो पेट्रोलियम इज़ द फाउंडेशन ऑफ द इंडस्ट्रियल सिविलाइजेशन. इट हैज़ शेप्ड civilization since the ancient time. Many interesting references connected with the earlier use of petroleum, especially oil and bitumen, exist in ancient history. The external fires of Baku were the result of the ignition of oil and natural gas from the seepage. The basket in which the baby Moses was hidden was made waterproof with bitumen. The Tower of Babel was constructed using bitumen as mortar. In the Far East, oil was used for lighting. It was rubbed into the coast of camels to cure them of manage. The North American Indian used petroleum as a medicine. The Mexican Indian valued bitumen as chewing gum. Christopher Columbus used bitumen to make his seaworthy. Marco Polo observed that mineral oil burned well to give both light and heat. It is said that when Alexander and the Great visited Persia, the events sprinkled the street with oil and set it alight. The occurrence of crude oil without gas is rare. On the contrary, large deposits of gas occur without oil, such as Sindh, Pakistan, PO, Italy, and Siberia, Russia. Oil is usually associated with gas in varying proportion, known as gas-oil ratio, depending upon its chemical nature and physical condition of its occurrence, like trap, natural barrier that prevent further flow of oil, depth and temperature. Presence of gas in oil makes oil mobile and easily recoverable. The downstream product of crude oil on distillation and processing are varied and numerous. Some of the well-known are fuel gas, petrol, domestic gas, LPG, naphtha, kerosene, diesel, fuel oil, waxes, and petroleum coke. Without oil, ships, train, aeroplane industry become. Now, we know about formation of oil and gas. There are two theories of the genesis of petroleum: the organic theory and non-organic theory. The former hold that petroleum is of organic origin and is the currently favored proposal. It predicts limited reserve worldwide. Moreover, Indian reserves are predicted as minimal. The latter maintain that it is of non-organic genesis, especially of primordial origin. On the basis of this theory, oil reserve would be much larger than those predicted by organic theory. India, oil poor in the organic theory, is predicted to be oil rich in the non-organic one. The latter maintains that it is of non-organic genesis. supposedly of predicted as minimal primordial origin. On the basis of this theory, oil reserve would be larger than those predicted by the organic theory. The non-organic theory that was much prevalent earlier suggests that oil is formed by the action of water on metallic carbides or by atmospheric radioactivity or by cosmic radiation. The rare occurrence of oil in meteorites, igneous dikes, and in petrozoic rocks weighed in favor of the non-organic theory. The organic theory, which is the most prevalent today, suggests that the petroleum was formed from remains of plants and animals that died millions of years ago and accumulated on ocean floods. Teeny minute marine animals and plant comprises mainly algae, fungi, diatom, and foreign mineral used to float on the surface of the sea and were abundant during the Mesozoic about 20-25 million years back and Cenozoic about 65 million year back period. On the other hand, rock surface and land are continuously getting eroded. Broken pieces of material like sand, clay, lime are carried away by rain and subsequently deposited in bed of ocean. In millions of years, the sediment pile up to great height, several thousand of meters, and subsequently pressure and the temperature continue to rise in the rocks, shells, and skeletons of dead plankton, sponges, and jellyfish sublime on sea bed and subsequently get buried under the peeling sediment. Aerobic bacteria present in the ocean floor and sediment act as scavenger and attack the organic matter. Some complex chemical transformation takes place that is facilitated by the enormous overburden pressure, rising temperature, and the absence of oxidizing agent. The process continues through various complicated stages and chemical reaction forming fats, amino acid, liquid, and finally into oil and gas. Oil is produced within the temperature range of 100 to 200 degrees Celsius. Source rock were subjected to greater overburden pressure and temperature beyond 160 for a long period does not generate liquid oil but gas. Amongst the different sedimentary rocks like sandstone, shale, clay, and limestone, the clays are more suitable for formation of oil and serve as source rocks. With the peeling up of sediment, lower sediment get progressively compressed and the fluid in them are squeezed out. Oil formed in the clay rises up or speeds away, and if the rock above is like a sandstone with pore spaces, fissures, and fractures, the oil tend to get accumulated in such a reservoir. Provided this upward and sideways migration is prevented by the intervention of an impervious layer of rock known as cap rock from moving further. This layer traps the oil in a normal pool, gas remains at the top, oil below it, and water further below. These pools remain intact till disturbed by earth. Now, next 1.3 Oil and gas exploration. Oil exploration is a complex process. It begins with prognatization and evolves as entire gamut of activities. The hunt for the hydrocarbons is focused at the favorable or promising areas based on geological consideration. Geological survey aims at selection and mapping of such areas which satisfies the criteria of being sedimentary rocks, preferably of marine origin, with the presence of anticline structure of mesozoic. 50% of oil produced belong to this era. Cenozoic 40% oil produced belong to and Paleozoic 10% of oil belongs to this period. Magnetic surveys are then done. Magnetometer survey is carried out either on the ground or from the air by airborne magnetometer. It is based on the principle that the distance from the surface. It helps to delineate the nature and possible deep angle of the surface rocks. Deep in the angle that a geological stratum makes with the horizontal plane. The inclination downward or upward of a stratum or bed, the same principle can be applied to the measurement of the gravitational attraction at the surface by gravimetric meter. These two methods together help in demarcating areas having thicker pile of sediment with better chances of oil. And the seismic method. The seismic method of oil and gas exploration involves generation of a series of shock waves in the subsurface and picking up the reflective waves by sensitive geophones which are laid along a line on the surface. This the time taken for the return signifies the velocity through the surface rocks, and these can be interpreted to assess the nature of rocks and their angle of dip. The field studies are supported by an equally elaborate testing of samples in the laboratory. Sophisticated modern equipment like electron microscope, mass spectrography, X-rays, chromatography, nuclear magnetic resonance spectroscopy, infrared, ultraviolet, and differential thermal analysis, that is DTA, are indispensable aids. On the basis of all these studies, the most suitable places where is likely to be found in selected for drilling. Next point, drilling for oil and gas. The drilling equipment consists of a tall huge tower called derrick, anchored to the ground, engine, mud pumps, water tanks, drawworks, and many other modules. The traveling block is suspended from the ground block, a large pulley at top of the derrick, which is shown in figure 1.1. The swivel attached by a large hook to the traveling block can rotate freely, and the Kelly is fitted onto this rotary table at the center of derrick floor. Hold the Kelly the engine. To begin drilling, the Kelly is hauled up the derrick its bottom and is fitted with the engine. To begin drilling, the Kelly is hauled up the derrick. Its bottom is fitted with a drill bit and lowered through the rotary table until that bit is resting on earth with the drill bit and lowered through the rotary table until with the starting of the engine. The rotary table rotates the Kelly and pressed hard cuts and penetrate the rocks at the bottom. This figure 1.1 shows the drilling equipment of derrick, and figure B shows perforation in casing 5 to test formation fluid. Now next point, 1.5, production of crude oil and natural gas. Crude petroleum is found in the pores, spaces of porous rocks, along with gas and water. It is trapped under pressure beneath impermeable rock formation. When the trapped formation is pierced, fluid flows out of the trap into the wellbore. The fluid in the wellbore is lifted out either naturally by the release of gas that lower the head or with a mechanical pump to maintain the influx into the wellbore. However, the withdrawal of the fluid from the reservoir lowers the pressure therein, and in turn the influx rate into the wellbore decreases. This rate eventually decreases to a value insufficient to pay for the cost of lifting the fluid to the surface. The recovered oil account to only 50 to 20% of original oil in place. In some oil reservoirs which have a continuous aquifer, the reservoir oil is replaced almost volume to volume by water, and pressure decline is very gradual. This increases its recovery efficiency to the range of 40 to 60% of original oil in place. The enhanced oil recovery EOR is practiced into two stages. First, A. Secondary recovery. B. Tertiary recovery. The most popular conventional type of secondary recovery duplicates the natural water drive reservoir. Water is injected in a series of oil in order to displace the oil to adjoining producing oil. Water, because its higher density, relative efficient discipline correction, and its nearly compressible nature, can raise the reservoir pressure quickly. Depletion drive reservoir will usually be more susceptible to successful recovery operation than reservoir operating under driving force. Particular gas cap drive reservoir present a problem since the moving oil and or the displacing fluid may pass into the depleted gas cap. Water, however, has two major problems that impede its efficiency. It did not flush all of the oil from the pore spaces as it moves through the reservoir rock. About 30 to 70% of oil is left behind and the developed cell within. A number of methods